Okay, so combinations. By definition, a combination is like a permutation. It's going to count how many ways something can happen, but how is it different than a permutation? It's different because order does not matter. I don't want to double count things that a permutation counted as different. Like when you were doing the combinations over there. When I was looking at the committee memberships, I don't want to count Hanson-Olson as a different pair than Olson-Hanson. Order doesn't matter. A permutation counts all different options. A combination only counts the options that are different from each other. So a combination of n choose r from a set of n things, how many combinations of r of them are possible? That's what this notation means. C is for combination. It's like P was for permutation. How many combinations from a set of n things in total can I make if I want to choose exactly r of them? So what we're going to do is we're going to find first how many ways this can be done in total. How many different orders as a permutation of those n objects where I need an order of r of them can be done. So by first counting up the permutations, I think about how many orders, how many ways this can be done that are possible. Permutation, from a set of n objects, how many orders of r of them are possible? What permutation counts too many? For example, one more time, I don't want to count Hanson and Olson as a different committee membership as Olson and Hanson. So I need to divide by r factorial. I want to divide out the combinations that are the same. So for a combination, what we're going to do is first figure out how many permutations of them are possible, how many orders are possible, how many ways in general this can be done. But a permutation counts too many of them. I need to divide out the combinations that are the same by dividing out all the different ways I can rearrange the r that I've selected. Sorry, go ahead.
I was just wondering, okay, so the r means like the repeated, right? Or what does that one mean? R.
Okay, let me go over here. How many people are there to choose from?
4.
How many do I choose?
2.
N is how many things there are to choose from. R is how many you're choosing.
Okay, I'm gonna have to write that down.
So from a set of 4 staff members, how many combinations of 2 of them can be made? We found that as 6. We first listed out the permutation order, 4 times 3. There's 4 people to pick from first, there's 3 people to pick from second. But that's counting too many of them, right? It's counting this combination differently than this combination. Does the order matter? No. So I need to divide out all the ways that I can arrange the same 2 people. I'm looking at 2 people. How many people can I pick from first? 2 then. So by dividing by 2 factorial, by dividing by 2 times 1, I'm left with the combinations that are different. So putting this back in terms of factorial notation, n factorial divided by n minus r factorial, that's what the permutation in factorial notation looks like. Our notes last week. I need to also divide by r factorial to turn it into a combination and get rid of the combinations that show up more than this. So like I said, the formula for me, I never use. I think what makes the most sense is to write it out first. I probably never use this formula, only just a handful of times, because for me, combinations make more sense if I just write it out. So let's try a couple of quick examples here. How many ways can each of the following scenarios be done? Let's look at a few of them, because they're all a little bit different. So we own 7 pairs of pants. We can only pack 4 in the suitcase. Does order matter here? Is this a permutation or a combination?
No,
Does it matter the order you put the pants in the suitcase? Or if they're in the suitcase, is that what's important? They're in the suitcase. I don't care what order they're in, they're just in the suitcase, right? So this is a combination, not a permutation. Let's first figure out what it would be as a permutation. How many ways can this be done? How many pants are there to pick?
7.
How many can I choose?
7.
How many fit in the suitcase? 4. So first off, there's 7 pairs of pants to choose from. Then
6, 5.
4. But that's counting too many things. That's counting my black pants, my red pants, my tan pants, and my gray pants differently than my tan pants, my gray pants, my red pants, my black pants. They're just in the suitcase. Does it matter?
No, not really.
No. That's like counting Olsen and Hansen as a different combination than Hansen and Olsen. So let's divide out all the ways that I can arrange these same 4 pants. If I'm only looking at the 4 pants, how many ways are there to arrange them? Not 3, 2, 1. How many pants are there, Allie?
7. Or
In the
we're
suitcase.
taking
In the suitcase.
4,
4 then.
3, 2.
Seven times 6 times 5 times 4 counts too many things. That's like me counting Gus, Stephen, and Luke as a different combination than Gus, Luke, and Stephen. Isn't it just the same 3 people? So I'm counting too many things. I need to divide out by 4 factorial, 4, 3, 2, 1, to be left with the combinations that are different from each other. Because order doesn't matter. They're just in the suitcase. Who cares?
Can you cancel off?
That's what I was just going to do. Shaylee says, how can I simplify this? What cancels out?
4 and 4, 3 and 2 cancel out 5.
So 4 and 4. 3 and 2 don't cancel out 5. What's 2 times 3, Hal?
6. Can I cancel out 6? Oh, that's wild.
What am I left with?
35 over 1.
35 over 1, which is just 35. There's 35 different ways to put any 4 of the 7 pants in your suitcase.
That is
Oh.
literally like bus.
Where did I get what?
No way.
Where did I get what from?
The 3. 7 times 5.
Let's go get some photos.
7 times 5 is 35. Or are you talking about this 3 down here?
Oh, that makes sense. That's 7 times 5. I'm like, that's 75.
Now let's do this on a calculator. Do you guys have a calculator out? Let's grab that for a minute.
No, but I do have an Arizona all natural, which are named as calculator.
You know where you guys found the factorials on your calculators the last several days? What we can do is let our calculator do a lot of these combinations for us. The combinations key on the Desmos calculator is right here. Did you find the same NCR key on your calculator somewhere?
Yeah.
I'll hit NCR. N and R. How many pants were there possible to put in my suitcase? Say again? 7. How many fit?
Only 4 in the suit.
4 of them. From a set of 7 pairs of pants, how many combinations of 4 of them are there? So let's type in 7, comma 4.
If you hit second, you can do comma.
So
Oh, I got
It's
that.
above the 9.
So what you're gonna have to do here is hit the 7 first, and then the 4 after.
Yeah, 35.
It's an error.
Yes, mom. Yes, mom.
You're gonna have to hit the 7 first.
ancient east.
Story on the bottom of the bottle.
Who else can I help? Who's our calculator?
Because it would be the barometer.
I've been some pretty scared.
So the set of 7 pairs of pants.
And there's pretty much
Easy, right? Easy one. Who else needs a little help with the calculator? You guys got it? Just like mine, doesn't it?
Yes.
All right, let's do a few more. 9 players are on a basketball team. How many lineups of 5? When you put a basketball lineup together, does the order of the lineup matter? Like baseball, hitting in order, like on a baseball team? Does the basketball lineup matter? No, you're just on the floor, right?
Yes.
It doesn't matter whether you're in the lineup first, second, or third. You're just playing the game.
Basically anything.
Okay, so let's first figure out how many ways this can be done. Let's figure this out as a permutation first. How many different players are there to choose from first? 9. Then, once you pick the first one, how many players are left?
8, 7.
As of now,
All right, now I've got the 5 players, but that's counting too many of them. That's like counting Maddie, Trey, and Hallie as a different combination than Hallie, Trey, Addie. When you're on the basketball line, it doesn't matter the order that you're picking. No, this is counting too many. So we have to divide out all the different ways to arrange those same 5 players. So I'm looking at the 5 players. How many ways are there to arrange them? 5 factorial, right? We'll start canceling some stuff out. 5s are gone. See you later. 2 and 3 say goodbye to 6.
Oh.
4 and 1 doesn't do anything. So
But the 4 can cancel out 2 of the 8.
Oh my god, we could do that?
4 divides into 8 twice, so can I use the 4 to take the 8 down to 2?
Wait, not 63.
What do we got here? 2 times 7 is 14.
9. That's
What's 14 times 9?
26. 1.2. Easy
I don't know,
math.
honestly, I can't.
126.
Right in my head, what?
Okay.
Okay.
Now, what would this be on your calculator? As a combination, using that NCR button.
9
NCR.
NCR 5.
9, 5. From a set of 9 players on the team, how many starting lineups of 5 could we make? So I'm going to type that NCR key. Get the 9, then the 5. It's 126. The calculator does what we did by hand for you. How slick is that?
Pretty slick.
Questions you have so far? Okay. 12 board members start a meeting by shaking hands. 12 board members start a meeting by shaking hands. Before the meeting starts, everyone's going to shake everyone's hands. Probably not right now because of the pandemic, but let's just assume that everyone's going to greet everyone by shaking hands.
I'm gonna say, you want to go? Okay.
Okay.
I went out for an interview.
How many people do you need to shake hands?
Well, 11.
2.
Wait, how many?
2. So from 12 people, how many combinations of 2 of them can be made? That's what we're trying to answer.
12 factorial. And then,
So pick the first person. How many people can I pick from first?
12.
Jack and
12 then,
11.
but I'm only going to pick 2 of them, Trent.
Okay.
chickens.
Okay? 12 times 11. Does the order matter? Me shaking Trey's hand is no different than Trey shaking my hand. Doesn't matter. We're just the same 2 people. This is counting too many of them. So what do I have to divide by?
Well,
What do I have to divide by?
10, 9.
I need to arrange the same 2 people.
divided by 2.
2 times
1.
1. Pick the people. Divide by how many ways you can arrange them. There should be 2 ways to arrange the same 2 people. I don't want to double count because there's no difference between me shaking Maddie's hand and Maddie shaking my hand. 12 times 11 is counting too many of them. How many ways can I arrange the same 2 people I've selected? 2 times 1.
66, yeah.
So let's see here. We've got, how could I cancel this out?
2.
2 goes into 12 6 times?
So 66.
66? Some of you used a calculator originally? Shouldn't that just be the same as, well, choose 2?
Yeah.
You guys got the last one? Put up on the board, let's see what you got.
Doesn't matter the order.
Shoot, I didn't know that was.
5 quarters are tossed in the air. 3 of them land heads up. How many ways can that be done? Well, how do we do? Write it all out as a permutation first. How many different quarters could you select from first? There's 5 quarters to choose from first. Once you choose the first quarter, what comes after that? How many different quarters? 4. Then 3. You're not taking all 5 of them. You just need 3 of them. So it's 5 times 4 times 3.
Anyone else get
That's counting too many. Okay, so we have another few more seconds here. How many ways can I choose 3/4 to land heads up from 5 that I toss in the air?
We got the same way.
Five.
on the computer,
And 4 and 3.
Good, then that means math makes sense.
I got 30 and 6.
Mr. Calculator can give the answer for you.
I got
5 times 4 times 3, because you need 3/4 divided by 3 times 2 times 4. This is counting too many. So how many ways can I arrange these same 3/4? 3 back 4, 3 times 2. All right, let's see what you got. I'm gonna write it out by hand first. How many quarters can I have land heads up first?
I don't know which Saturday, Sunday.
5. Once I have one of the quarters landing heads up, how many left are there to choose from to land heads up?
Oh.
Then,
I got you.
no, I only need 3 of them, so I'm gonna stop counting after 3.
I'll check.
Got it now? Awesome. Now that's counting too many. That's counting quarter 1, quarter 2, and quarter 3 as a different combination as quarter 3, quarter 2, quarter 1. So I need to cut this down by a little bit. How many ways are there to arrange these 3 quarters I've selected?
2.
3, then.
Two.
You bet. You always divide by the number of things factorial that you selected. Let's see here. 3 cancels out 3. 2 goes into 4 twice. So isn't this just 10? Of course, some of you probably just did a calculator. What goes first? 5, choose 3. There's 10 different ways for 3/4 to land heads up. I throw 5 into the air. Let's grab your laptops out, please. Let's do some con here with the last 10 or 12 minutes of class.
You know how I talk about the probability of a quarter landing on its
I'm
side?
scared for our
That
mental
is-
health.
Not one day.
I'll assume that that is so small
Dude,
that we don't